This is the setup we're going to use in the find the muzzle velocity of a projectile launcher activity. We use the small ball bearings. They go inside you just drop them inside the muzzle launcher. You notice you have a plumb line here to make sure you're vertical. The ball bearing should come up and basically hit the projectile launcher. If it doesn't, if it's landing way over here, then you're not really doing a vertical projectile, which is what we want to do. There's 3 different settings. For each setting, I have a screwdriver, you can use a pin. I can push it down once and it will click. The arming mechanism's right here. It comes out and it clicks once. So that's the first setting. Then you just pull on that and the projectile launches. Okay? So you will use video physics. I recommend that you run your video physics running long ways so you can get as close as possible. The closer you get, the easier it is to see the ball. Then you'll mark each you mark all the data and generate an equation. From that equation, you should be able to calculate the muzzle velocity. Obviously, you'll have to have a frame of reference here. Obviously, when you do the video physics, you'll need to be farther away than what this video is so you can see how high the ball actually goes. Also, it's really important you have a white background, and we don't have that many places in the room that has the white background, so you probably need to go in the hallway by the white pillars. Would work really well. It's a good place to do that. One other thing, when you set this up, make sure you have a gap from the bottom of the muzzle launcher to the plate. If you put it right up against the plate, the muzzle launcher won't function effectively. So again, you have 3 settings. That was the first setting. I can go down 1. The screwdriver doesn't work very well. A pin works better. That's first click, second click. Then you'll have a different student do that one. It goes up and comes back down. And then you can do 1, 2, 3 clicks. That's as far as it goes, and that goes the highest setting. So each student should get a chance to mark the data and generate an equation, and from that equation you can find the muzzle velocity. And then once you've found the muzzle velocity, use that to predict the maximum height, which you can also get from your equation. Once you've found what the muzzle velocity is, the next step will be to do a check to see how consistent the muzzle launcher is. With that muzzle velocity, you should be able to predict what the height is, so we'll do a close-up, measure up on the wall the distance that it should be, do 5 launches, and get your min and your max and your average and see how those compare. Here's an example of how you would test your muzzle velocity prediction by seeing how high it actually shoots the projectile. So you get a real close-up. Again, you'll notice this video is taking long ways with the ruler. So you let it go, and from there you should be able to slow it down. This, I didn't use video physics, but if you use video physics, you should be able to slow it down and see exactly how high it went.